The third annual conference on new paradigms for using computers was held at IBM's Almaden Research Center. More than 100 experts from industry and universities gathered to discuss how to increase the capabilities of computers and make them easier to use. Ashok Chandra, manager of computer science at Almaden, welcomed the visitors and gave them his view on 3 different eras in the history of information processing.
So the first era, according to this history, had to do with hardware and the emphasis on it, making it more effective for use. The second era was the era of software, where we had all this hardware to play with, and now it was a matter of how do you cope with all this complexity. And certainly the emphasis on it, even 10 years ago, wasn't as much as it is now. The number of companies, the amount of money, the amount of software systems and so forth certainly have grown a lot during the last decade. I believe we're on the threshold of the third era, which is the era of the user, where the emphasis isn't on the internals of the system and how you build them. Certainly that will be so. Certainly there will be emphasis on the hardware. But increasingly the emphasis is shifting to the user. How do you make it easier to use computers? How do you make it fun? How do you make it so the computers don't intrude on the consciousness of the user quite as much, where the user is thinking about doing their task rather than dealing with the computer? In some sense, computers, one way of looking at it is that they will disappear into the woodwork, kind of like electric motors did. We have a lot of electric motors in our homes, in our cars, but we don't think about going out and buying an electric motor. We do think about today about going out and buying a computer. But that is just one model of this emerging new era. Another model is, in as much as you use computers, they should be easy, but not just easy, they should be fun to use. It should be a pleasant experience. I believe this emphasis on the user is certainly going to increase as we proceed. And that's what this conference and workshop is all about this third era in computing. How do you make computers easy and fun to use?
Ted Selker was the organizer and host for the meeting.
I'm really honored by the kind of group that we've been able to bring together. You know, the goal of this meeting, in my view, is, as the abstract says, to get people to remember and realize that we are a community of people that are always working on things that we find ourselves getting courage from other people working on them to complete. And, you know, I'm not sure whether the first year when we were here and Terry Winograd said maybe that the internet was going to be interesting and Mosaic kind of didn't exist, that we believed him. Now it's very, very exciting. And, you know, one question is going to be, in 5 years, will we still be talking about the internet under, with each breath as we go?
The program began with a discussion by the previous year's participants.
It seems to me that that we're at a very important point in time. In fact, all points in time are very important because they're the boundary between the past and the future. But as Alan Kay says, if you want to predict the future, the best way is to invent it, and that's, I think, what we're doing here. So we're going to see a lot of new ideas, just as we did last year, about how to paradigms for interacting. I'm hoping each time that we'll see the translating devices and the using devices become increasingly smarter so that the user can become increasingly dumber, which does seem to be the trend in our society as a whole, and we have to accommodate that.
When I talked here before, some of you were here may remember, I talked about the information wilderness out there in the network. And what I've come to realize in the intervening times, of course, that was sort of the wrong metaphor. It's still a pretty chaotic and confusing mess, but the population has become more like Times Square than the wilderness. So what you have out there is hardly this sort of image of braving your way through the woods and occasionally facing a tiger. Instead, the image is you're in the middle of this huge bustling crowd trying to figure out what's going on and who's there and what you can do. So the things that I've been thinking about, and I'll talk mostly about stuff that students are working on in our projects, I would put sort of roughly the general category of how do you interact with other people in this wilderness or in this chaos, as opposed to how do you interact with the chaos. And in particular, what kind of connections do you have that go beyond the sort of chance encounter? So we've got a couple of projects, some pretty much simple pilots, but sort of moving out a little in that direction. One has to do with being able to have group annotations on the web. So you go to any old website anywhere and stick a Post-it on, but your Post-it, as opposed to being stuck on the graffiti wall, this is all metaphorical, of course, it's little yellow squares on the screen and so on, right? Instead of being on a graffiti wall, is in a specific set stored on a specific server, not the server that has the original site. You can stick it on anybody's page, no matter where they're, without any control over their site, with a structure of access control. So I can, for example, within my research group, say, let's all go look at some bunch of stuff about what's happening on the web and share our annotations about it. If you're in that group, then you tie into the annotation server, you log into the appropriate thing, all the details aren't important. But what's important about it is that it gives you the way to create spaces in this virtual place which have to do with who's in the space and what kinds of things they're doing there, and then to keep them separated so that when you're working at any given moment, you can focus in on one of those spaces, one of those conversation spaces, let's call it, or multiple ones, in a kind of invisible way. Because what you see on your screen looks like the original materials with these little stickies on it. In fact, there you see little tiny faces, and if you poke them, they become big Post-its and that kind of stuff. But it's trying to provide this notion of, in general, of what we're calling third-party information. Right? Somebody puts something on the web, somebody reads it, and in between you can interpose these multiple perspectives, multiple third parties who add something to the information, and that becomes visible when, think of it as like a plate of glass that's stuck on top of it, but you get to choose which plates of glass are there.
What I'm working on is an agent for a web that acts a little bit differently. Instead of you trying to declare your interest in a certain topic and have the system search the far corners of the web for it, the idea is that this is an agent that sort of sits around as you browse the web in something like Netscape or Mosaic and just tries to keep sort of one step ahead of you in your browsing activity. So you don't really have to tell it what you want. It just watches your activity in browsing and collects the URLs that you're looking at, collects keywords and that kind of thing. But the idea is that it's supposed to do just a little bit of exploration of the links ahead of you to try to make some suggestions as what you might or might not be interested in. Now, the other project I'm working with has to do with sort of not new paradigms for using computers, but new paradigms for programming computers. One of the things that I think is we have kind of a $50 billion problem that nobody's doing anything about, which is sort of the technology for actually programming computers. And so you might, I don't know, conservatively estimate what the U.S. spends on programming at, maybe $100 billion. And you ask, what are those people spending their time doing? And when they send sociologists in to survey them, they find out they spend half their time debugging. Okay. So if programming is a $100 billion problem, then debugging is a $50 billion problem, but nobody's done anything about it. So basically what we're doing is sort of building a visualization system that gives you a sort of animated view of your program together with, and it's reversible, so you can run things forward and run things backward. And this is not only applicable to programming, but also to any situation where you sort of have a static description of something like a database or spreadsheet or something, and then you want to understand what's the dynamic behavior that's happening as a result of that static description. And so what you'd like is to be able to have a reversible animator for both the static description and the dynamic behavior. The idea is that we're running a piece of code here, And the idea is you get like tape recorder controls that go that let you go forward and back. And when we have a little, we highlight the piece of code that's being run, and we also have a little window that travels along with your code and shows you what it's doing. And we can also run it backwards. And when we run it backwards, the graphics disappears. Okay, so we have the graphics and the program that can run both forward and backward.
The first speaker on the program was David Kelly, president of the IDEO company. He spoke on the need for rapid prototyping to speed up the product development process.
We really believe in this sort of grubby machine shop approach, is sort of the way I like to describe it. But what we do, we believe that if you have an idea, that you have to be able to sort of do lots of them, but the most important thing is to quickly. It seems sloppy. I mean, most people in companies think it's sloppy to start by the first thing you do is build something and start showing it to people, even maybe users, which is a really difficult idea, because that's really messy. If you show it to users, they'll tell you all the things that are wrong with it right away. And then you get to go back in and fix those, which seems like a reasonable approach to me. But so this sort of over-specification. Michael Schrag, who's a person I work quite a bit with, has written articles recently about a prototyping culture instead of a specification culture. And I think that's a really interesting way to look at it. I believe it's true. Companies that tend to have a culture of, we'll build this prototype, show it to users, all the smart people we can find, and then do another iteration over, seem to be succeeding more quickly than ones that sort of think about it for a long time and then build one thing at the end. It's really hard in many companies to sort of have the guts to come out with this sort of straw man solution to a problem and sort of take the beating of everybody telling you what's wrong with it. But for some reason, especially in the engineering world, we're really good at telling people what's wrong with their idea. So you just have to use that fact that everybody's really good at it. You just bring something up, write down meticulously all their problems, and then the next time they'll have to come up with something else because you've fixed all of those. And you can be wildly creative about what it is these prototypes are, because you only build something that you use to ask questions. You don't just build a prototype just because that's the thing you ought to do next. You do it to ask a question. So if you look at for Trimble navigation, the picture on the left, that's actually a user interface mock-up. And we were doing it very quickly. So what we do is those little slips of paper, you press a button, and then somebody slides the piece of paper to the next screen, depending on what button they pushed. So you're actually just moving pieces of paper around, which is a really quick way to mock up an interface in certain instances. And we certainly use cardboard to see how things will go together. We do a lot of work for the consumer packaging companies in addition to doing all this computer stuff. And they have a solution to it. It's called statistically significant research, mall intercept studies. So they're going to sell, or last year they sold 500 million of these tubes of toothpaste that we helped them work on, this neat squeeze thing. But the interesting thing is they can't afford to, they really need to know the answer. They can't guess like most of us do. And so they spend the money to go out and do this statistically significant research. The problem is, even if you do that, if you don't take the conceivers, if you don't take the designers and the sort of R&D people out and actually have them feel it, if they don't, getting market research back in sort of this, it comes back in, like about 3/4 of an inch thick, all type, you don't, it doesn't help you very much. Yes, they like it. No, they don't. They like this feature. They didn't like this feature. It's not the same as that sort of tacit learning of going out there and watching somebody use it. And you only have to have about 50 people use it, not, 50,000, and to sort of educate the people who are responsible for the next idea. And that seems to be something that companies are reluctant to do.
Douglas Engelbart is one of the computer industry's true pioneers. He invented the mouse and created the program Augment, which influenced today's World Wide Web. He's the founder and co-director of the Bootstrap Institute.
We started the Bootstrap Institute 6 years ago, my daughter Christine and I, and now it's beginning to get the interest in this, and it's really a strategy for how to improve and go after the collective IQ. And it's really interesting that a lot of the things that Kelly talked about for products on sort of an individual basis, it's just exactly the kind of thing, the way you have to evolve things for organizations and large groups, and the way you have to move it in there, and the experience has to do it, and you have to empower the people, And so there's a whole infrastructure about improvement that turns out to be important. So these are all sort of integrated into what I call a paradigm map. We start with saying the objective that's been pursued for a long time is high-performance organizations. And it's really, to me, it was the collective capability of organizations to cope with complexity and urgency that's been my dominant professional motivation all through the years. And it's the kind of thing that is just now beginning to get to the point where organizations are ready to start listening and thinking about this. So another big issue came about here, that it isn't any one single capability in a capability infrastructure that you can target, that the pervasive impact of the kind of technology we're talking about hits at all kind of levels of the infrastructure of capabilities. That's how an organization can do anything effectively. Organizations are going to spend a huge amount in trying to change and survive and change in the future. And you can look at it and say, well, yeah, it's going to be expensive buying all that technology, isn't it? And if you have any experience out there, you realize it's going to be from 5 to 10 times at least more expensive to do your migration vertically in the organizational changes that call for relearning, new modes of working together, relating together, a whole bunch of things that are different. Organizational structures and roles will change, and that's extremely expensive to dinker around with. And so you say, my big organization is going to move out in there. And the zigzagging that the product marketplace has done with us in the past is going to be horrendously expensive. So to me, it seemed like you have to find a strategy so that investment and change, you can maximize your return on investment. And that just becomes this question, what strategy would do it? So with us, many years ago, I just looked at it and says, well, for one thing, there isn't an infrastructure for changing organizations that's sort of up to the problem. It's all sort of hit or miss, and we'll get a corporate-wide committee to work on improving this part of our manufacture, this part of our design, then it gets disbanded. So underneath that, we really worked on the kind of improvement infrastructure, which led then to saying, oh, if you get the right kind of improvement infrastructure, then there's some of the new organizational capabilities that are there to go after. Why not get those early that could be plugged into the improvement process so you can be improving the improvement process in a way that's consistent with how you're going to end up improving your end working processes. And that's where the term bootstrapping came from.
Another computer industry pioneer is Nolan Bushnell, who founded Atari, the company that virtually created the video games industry. He is also the founder of Chuck E. Cheese pizza parlors and game centers. Bushnell talked about his latest endeavors, Vent and E2000.
Vent is a project which is focused on multiplayer gaming. And multiplayer gaming, networked gaming, people playing, has some real serious problems. And the main problem is cost. And one of the things that also seems a little bit funny is nobody seems to like to talk about cost here, but I love to talk about cost because that's the publishing organism. And what you look at as a business plan is the life support system for an idea. And as you can create an economic model that gives a lot of profit, that says that it's a lot less difficult to ever get it into place. Like raising money from foundations is exceedingly hard, whereas getting it from greedy entrepreneurs is much easier if you have an economic model that's really powerful. So we've created a low-latency game-playing network that will be deployed this fall, in which we will have, by July of next year, over 35 to 50 million households illuminated with a wireless game-playing system that we will be able to deliver a wireless modem for under $50 retail and 20 hours a month for $9.95 and unlimited gameplay for $35 a month, which is $5 below the cable TV churn number. Now, what does that mean? The fun part just begins, because now we can play a whole bunch of people at the same time without running into the telephone company bottlenecks, multiplayer games like you've never seen, and we're going to have Boston against San Francisco, 10,000 people against 10,000 people in an arena, duking it out, and it'll be good television. We will have David Brinkley or one of the guys in a virtual console flying over the battlefield or the sports arena, as the case may be, reporting on it. And if you just go through the mathematics of friends, girlfriends, neighbors, if you've got 10,000 people and 10,000 people, you're going to have a Nielsen rating that will attract advertising. If you have advertising, the economic structure comes back and it says the people will support it because advertisers pay big money. How much would Microsoft pay for a virtual cyber sports arena contest 30-second ad? I think a lot. Okay? So now we have a whole bunch of people playing a whole bunch of people in a whole bunch of games that are economically subsidized by third parties, and you got an economic model that really kicks butt. Anyway, so that's Vent. Okay, what's E2000? E2000 is Chuck E. Cheese on steroids. And what we're really trying to do here is, you know, businesses are funny. And I'm convinced that managements composed of accountants and attorneys represent a mutation stop in the evolution and the mutation of a company. And so what happened is that Chuck E. Cheese has sort of been locked in some kind of a time warp, stuck in around 1975, 70, or 1985, 86. And it turns out there's a whole bunch of things that are happening. And again, I believe that network gameplay is the neat one. People playing people. People competing with people. Leagues, teams, groups. Having fun. Together. Socially. Socially separately, socially together. And so E2000 is the game center for the network playing generation. If you go into a Chuck E. Cheese at 6 in the morning, there's nobody home. If you go to Chuck E. Cheese at 11 o'clock, there's nobody home. If you go into a Chuck E. Cheese at 3 o'clock, there's nobody home. Basically, you do a little bit of business at lunch, and you do a whole bunch of business on Fridays and Saturday nights because of birthday parties. Okay? Most of the rest of the time, it's catch as catch can. Well, what we decided to do with E2000 was to create a physical plant that's totally software reprogrammable. And so the ceiling is black, the black T-bar, the floor is gray carpet, and the walls are painted either black or white. And on the white walls, they are washed with either color, a computerized slide projector, or a high brightness projection television set. And so when you walk in at 6 in the morning, all of the networked workstations, and we have some virtual dining theaters as well, turn into a virtual school. And so now we have computer education at its best. We'll have 150 to 250 networked workstations that will now be devoted to hands-on computer training. We'll have hypermedia classrooms, which you're playing game shows during the entertainment phase of the facility as a school. We will be able to provide the lowest cost computer education in the nation because the life support system for the whole damn thing is the education or the entertainment at night. It's Chuck E. Cheese at night. We've got a restaurant, the whole thing. And so you pay one rent, you buy the hardware one time, and you amortize it all over the day. And so all of a sudden you can cut anybody else's price for computer education way, way down. And in fact, 20% of our kids are going to be on some kind of scholarship. And we'll cut deals with the schools. We'll cut deals with anybody who wants to come. We'll have toddler classes before noon. We'll have after-school things for latchkey kids.
James Gosling from Sun Microsystems talked about the capabilities of Sun's new web browser, Hot Java. This technology has created a hunger for web programs that run on a user's computer.
But within the browser, there are like 3 categories of things that most people do. They either define new protocols, new data types, like new different kinds of image compression. And the most common thing that people do is these sort of new embedded items. So if I hop to some page like here's a fairly simple one where sort of on the page there are these things that look like illustrations of chemical models. Here are these things that kind of look like images, but in fact I can sit down there and interact and play with them. And what's going on here is that within the HTML page there's a reference to an application, and it says plunk this application down here, and then the code for the application gets sucked across the network, and the code is all represented in this virtual machine. People have been using this in a number of different ways. One of the sort of implications of this is it sort of shifts where innovation can happen. And there's a screwy thing sort of happening on the internet these days where there's this group of people, the IETF, the Internet Engineering Task Force, and they're defining standards. And you need standards in order for the people to cooperate and communicate. But the problem with that is that the standards end up being sort of least common denominator. They're very difficult to get people to agree on. And often standards are actively counterproductive. So then you get, companies who go off and they want to invent some protocol and they want to do something cool. So they have to, do their own protocol, and that means that they have to, do their special client, and they have to do their special server, and somebody else does the same thing, and now you've got this universe where, data over here on the vendor B server has to be accessed using this client, and data using the vendor A server has to be done using this client, and you can't have references from A to B, and the poor guy over here has to have, a bunch of clients on his desk to get at the different kinds of data. But the way people have been doing protocol modules in Hot Java, it lets them just do the protocol module or just do the little extension that they need, and then the sort of browser framework lets the pieces integrate, so that what the user sees is this sort of unified, seamless experience. And I've been popping to web pages here, essentially running people's applications, and I wasn't at all aware of running the applications. And when I sort of went to went to this page, these guys' application got loaded into my machine. I didn't even know it was happening. And the whole notion of an application sort of goes away.
The title of Mark Davis's talk was Video for the 50 Million Channel Future. He envisions a world where video clips will be as common as print materials. That will enable people to produce their own videotapes as easily as they create publications from printed sources today.
So what we're talking about is a global media archive. This is where I think computers are headed, or at least where I want them to head. I often think that one of my qualifications for my job is that I watched a lot of television as a kid. But I wasn't able to actually get my hand inside that TV set and make Bugs Bunny do what I wanted and tell my own stories. What I'm interested in is making a TV more like that. So it's an image where digital video is produced anywhere in the world by anyone, and it's accessible to anyone, anywhere, for repurposing and reuse. Repurposing is a buzzword you'll hear. All it means is that if someone develops some piece of content for a given purpose, then another person is going to use it for a different purpose. So this is an image that today's video users become tomorrow's video producers. That's why the talk title is the 50 million channel future. All the talk about interactive television, 500 channels, that's not very interesting. The reason that's not very interesting is I have a lot of bandwidth coming into the home and very little coming out. And that means that all the content and all the programming is going to be determined by a centralized source. Think about what computing did in the sense what the internet has done. Computation, the ability to manipulate text and numbers, used to be something inside the vaults of major corporations. Now we all have it on our desks. Well, think about Hollywood and network TV stations. The ability to manipulate movie and image data and sound is basically in a highly localized, small elite group of people. What we're talking about is a future in which that ability is something that's widely decentralized, and that the production of video content happens on everyone's desktops and accessible to everyone else. Then you have a universe of 50 million or 250 million television stations, which are computer desktops. Well, that's wonderful. I'd like to get there, but coming into the Media Lab, I wanted to have that all happen, but there was one little problem I had to solve first. That's that computers can't yet understand video content. And this is a very major problem that many people in the multimedia industry don't really like to talk about because they don't think about scaling issues at all. If I have enough video on my CD-ROM, I'm basically okay with keywords. If I have 50 million CD-ROMs worth of content, I'm in a lot more trouble. So the problem with video, of course, is that it's opaque. Computers can't really get out content, and there's lots of information. It's very data-rich. We don't currently have structured representations for talking about content. And the real gotcha is that without content representation, manipulating digital video is like word processing with bitmaps. Think about it. There's no ASCII, no RTF, nothing. We don't have spell checkers and grammar checkers for video. Why not? Because we have no content structure. We have no representation of the structure for video data. And what we currently have is woefully inadequate and will not get us where we want to go. So I'm going to offer you a solution. And the answer there is video indexing and retrieval. What we want to be able to do there is devise representations which enable us to manipulate video according to its content and its structure. And the key point here is that we want to annotate video for reuse. The work that I'm talking about is I really want to have video be a renewable resource. It's like, think of video recycling, basically. I want to have video be available for lots and lots of new purposes. So the annotations and representations of video that I'm interested in are those that facilitate reuse of content. Some of them are generated by computers, some generated by humans, and especially by humans and computers working together. If I want to describe video, I want to describe what's going on in a shot, what it means is going to depend on the sequence that it's in. So if I describe a given sequence of video and then I rearrange it, it's going to mean something different than when I originally had it in the first sequence. So video has a dual semantics. There are some things about video that are sequence independent, that don't change. There are some things about it that change in a tremendous regard. The fact that there's a face and that it has a certain expression is constant, but its semantic function of meaning happy, sad, or hungry changes depending on context. So the challenge then for a video database and for a video representation system is to separate out those things which survive recombination and those which don't.
Ramana Rao of Xerox PARC described how to use the emerging technology of visualization to improve communication.
Okay, so visualizations aren't just pretty pictures, right? The argument is that there are ways to extend our ways to think, right? So visualization is not just perception, but it's also cognition. It's as much about thinking as it is about seeing. A visualization is a representation, not just presentation. So useful things pop out when representations are well designed and seeing is learned. So there's a shared burden between writers and readers, between designers and users. This to me seems like another indicator of the representational nature of diagrams, that use and understanding of them must be learned, just like language or arithmetic. So you could see our strategy has been to go through the great kinds of information structures there are, like hierarchies or tables, and basically come up with new visualizations that allow you to deal with more stuff. And we've done about 8 of these by now. The basic goals are to increase the scale, going from tens of objects to thousands, and to make exploration easier. And as I said, the party line is about moving the work over to the perceptual system. Across all these visualizations, all 8 of them, you'll see some recurring elements. And these kind of act as rough, vague principles that kind of guide us in our design process. And there are these 4 that I'll go through real quick. Focus plus context is about integrating areas. Well, there's an essential trade-off between showing a little about a lot or a lot about a little. Focus plus context is about trying to integrate that trade-off in some smooth way. So you put a focus area, something that shows a lot about a little, in the middle of a lot more, showing something about it so you can stay oriented. And it's a dynamic display. You've got to be able to move around it. So you've got to manipulate that focus. Graphical representations, I think almost everybody appreciates well the value of these, and I'm going to actually talk about that much more later. And then animated transition, it's saying that if these things are dynamic displays, it's easier to see the here and the then and the now, or whatever. From what was before and after, you can see better if you animate the transition. That cone tree just popped into a new stance, and you looked at it, and it just did that automatically. You might go, what happened? Did you edit the structure? Did you accidentally hit one of those keys, and it deleted half of the organization, or what? But if you animate it, you could see what happens. And then the 4th principle is about time-governed architectures. And actually, this principle is pretty much what Bushnell was talking about when he said clever hack for being able to deal with the computational load. So we sense how much load there is, whether we're able to keep 100 millisecond frame rate. If we can't, we throw things out. Bushnell puts fog in, or turns off the lights or something, but we do other things, basically.
As part of the panel discussion that concluded the meeting, Selker invited Steve Mann and Thad Starner of the MIT Media Lab to discuss the head-mounted displays they wore throughout the day.
I'm kind of interested in augmented vision or seeing through. I call this apparatus the visual filter because I see if I wear this long enough, I sort of become one with the machine. And I can do things like turn the images upside down and live in an upside-down world, sort of repeat the work of George Stratton that he did back in 1896, where he put these glasses on for a week and acclimatized to them. I'm living in a ROT 90 world right now, seeing the images rotated 90 degrees. And I sort of repeated his work with a few different variations. And sort of along, in doing that, I guess the very first experiment I did was living in a grayscale-only world. Because I couldn't afford any color equipment. So I experienced what it was like to be colorblind for a week. And I found that it gave me a heightened sense of awareness of light and shade, much as a blind person has heightened hearing. So I became very aware of sort of living in a world like Ansel Adams might have photographed, seeing very, very fine detail and shadows and so on. And I found that was kind of artistically useful. And this idea of visual filter now, sort of seeing everything through this lens and becoming one with the machine, in a sense, this has become my eye, and in a sense, this has become my optic nerve. And if anybody's read Virtual Light by William Gibson, now that gives me a tap into my optic nerve where I can send my field of view. I have a wearable wireless webcam, maybe the world's first and only wearable wireless webcam, so that send stuff onto my web page, or also just insert things onto the video. And I've done some collaborative work here with Thad with his finger tracker so that I can draw in three-dimensional space with my finger and see that, and sort of see the real and the virtual worlds on an equal footing.
One of the things I should mention with this design issues is that I think that a lot of these wearable computers and these headsets are going to be tailored to the person. Like you go in and you get a suit measured for your body, you're going to go in and get your computer measured for your body. And I think you'll see a lot of people who like my system better than your system, or your system better than mine because it does binocular, for example, or transmissive systems or something like that. One of the key things that you have to remember is this hardware is going away. You won't be able to tell whether somebody's augmented or not. Right now, during this conference, a lot of you probably didn't realize I was typing your name badge unless I asked to see how you actually spelled it on these things. And I find that a lot of people don't realize that I am using this thing almost all the time. Pretty soon, that's one of the reasons you don't realize I'm typing is because I'm looking at this strange thing welded to my face, right? But that's going away. There are little laser systems that are coming that use little big mirrors in front of the lenses that are really small. Phil Velda at the AI lab has a little system that mounts back here that's a CMOS chip, basically. You access it like a DRAM, uses color through diffraction. Keyboards going away. You can or get little ones that are just 5-button typing standard. Put those in your belt. And this bulky thing, as people object to as my computer, it's also going away because these are coming into the fore. This is a little credit card computer. The new ones these are 33 megahertz, 486 boxes with VGA, hard, serial, two serial, parallel, lots of other nifty things there too. All in that little box.
Who makes them?
This is made by SMOS. Another person is Oki. So basically you add yourself a little HP Kitty Hawk and a Metrocom modem when it gets to the PCMCIA, and yourself a battery. You basically have a full communications device and a cigarette pack that goes in your pocket.
The meeting concluded with the participants responding to a question about which of the technologies discussed would fall by the wayside in the next 5 to 10 years.
I actually think everything that I can think of right now that we heard today will still be with part of what it's doing in the research phase. There'll be pieces of it that will start coming out. I mean, some of the visualization stuff, some of Mark's stuff, I mean, I just predict some of those things will be out there in some form. But I don't think the really hard problems in any of these areas will be solved in 5 years, actually. Because I've seen how slow everything goes, and everything's getting slower, right?
I think some of the stuff that we've seen today will fall by the wayside, but there's different ways of falling by the wayside, okay? One is falling by the wayside because of success, okay? Some of the things will fall by the wayside in terms of being scaffolding, like to get us to the next level of what we're doing. So something like Java, I mean, I think is very useful because it'll permit people to have active documents over the web and stuff, but I think everybody fully expects that in maybe 5 years or 10 years, we won't be using languages like that because, we'll have gotten past that stage. We'll be using some future thing that's iconic and multi-parallel and all sorts of things. So we won't need something that's particularly like that particular language. So those are good ways of falling by the wayside, either becoming, having it successfully adopted as a paradigm or acting as scaffolding to, sort of the next level and stuff. And then there are some things like Romano's saying where they're just, well, it's, just working on visualization as a general topic is, kind of, 20-year or 50-year enterprise, and you're just into the first 5 years of it. And so that's why it hasn't fallen by the wayside. You still have to talk about it. But I think all those three categories of stuff will fall by the wayside, in various of those ways, but I think that won't mean that they're not important. I think because for those very reasons that they are important.
I think one of the things that will change is that what we think of as television, what we think of as computing, will not be separate. That will be a major shift. That the stuff streaming into our homes over analog signals, that we record on 12 flashing VCRs, that will be fully integrated into not just our workflow, but into our play. And I think that the ways in which people play now using computers and using video will change very radically, and so that separation will go away. So that's one of the things that I think will be different. And Marvin already mentioned the notion of the big box that you go to do stuff with, I think will be substantially reduced, and that there'll be lots and lots of computation embedded in many sorts of things that you do all the time, some on your body, some in the environment, some in places like shoes that you would never think you would have computation, and that the notion of a computer as a separate box and device will start to fade. I think one of the ways you mark that is when in a language you no longer mention the device that you use. If you think about telephones, I say, oh, I spoke to Marvin yesterday. I may have done that on the telephone, but I don't need to say that to you because that becomes, I'm like a cyborg then with the telephone. That's part of the extension of myself. And we'll start to see that with computation once it becomes transparent enough that we don't think about it as being a technology. It's just being part of what we do in our daily lives.